Hi everyone. Today we're going to be doing some stuff with some more stuff with exponents. We're going to be moving on to a unit called exponential equations. So you can see up here, we are going to be working with some exponential equations. These are going to be some notes on this. If you want to try to copy some of this down in a notebook, that might be a good idea. A lot of it's going to be graphing based, which is going to be very weird when we're at home. So we're going to be using some different technology to go over that. Probably some Desmos calculator stuff and just being able to input values into tables and such. It's going to be a little bit different than usual. That's okay. So this is what we're going to be working with. We're working with exponential equations. Exponential equations look like this right here. An exponential equation is an equation that, you may notice this, but the variable, the x, is going to be that's going to be the exponent, and so it's a little bit different from linear equations. In a linear equation, the variable, you would have like 1/2 times x. In this kind of thing, you have some number, a and b are going to be numbers, but a and b are raised to a power. So that's going to be a little bit different. The first thing that we want to go over, this is a simple version of exponential equations. We'll move on to some more complicated examples, but each part of this equation stands for something. So in this example, A stands for the starting value, and we'll get more into what that means later, but for now that's just called the starting value, times B. B is, it's a base, it's being raised to an x, but in this example, we call this the growth or decay factor. So I'll explain more later as to what it means between the growth and decay stuff, but this is going to be either a growth or decay factor, and we'll explain what that means later. And then x is, of course, x is the exponent, and this is what you are going to input. So that's where you're going to be plugging stuff in. So let's go over some examples. So for this first example, we're going to have y equals 3 times 2 to the x. So what is the starting value on that? Well, the starting value refers to that a. So in this example, the starting value is 3. And what is the growth or decay factor? Well, the growth or decay factor right here, well, that's going to be a 2. That's what that refers to. And so we're going to go through and we're going to fill out this table. So what we're just going to have to do, you're going to have to plug these numbers into this variable. So the first example is going to look like, 3 times 2 to the power -2. Now I'm going to do that up on a calculator. I'm sure you have a calculator on your phone. There are different types of calculators. I'm just going to use Google because it just works. It's fine. So our example is going to be 3 times 2, the symbol next to the 8 is the times, to the power -2. We'll start with that one because that's the first thing that we're going to plug in. Boom. So you can see here, 3 times 2 to the -2. That is what it's being raised to. Remember, 2 to the -2 is the same as 2 times 2, but as a fraction, so that would be like 1/4, and then 3 times that is 0.75. So let's change that number. The next thing up is -1, so we can just 3, 2, 1 ribs, whatever. 3 times 2 to the -1, so that number is going to be 1.5. You can see how these are going up. Next number up is 0. So that is just going to be 3, and that should make sense because when you raise a number to a 0 power, so like 2 to the 0, that's the same as just 1, because anything to the 0 is 1, so 3 times 1, just 3 down there. Next number up is 1. So we are going to get 6, and the next number up is plugging in a 2, 3 times 2 squared, that is going to be 12. So something that you should notice here, the growth or decay, well, first of all, something special here. The starting value, that 3, that is where the graph lies when x is 0. So we can also call the starting value where the graph, or where the equation, use equation, the y-axis at x equals 0. So we'll actually show you what that looks like on a graph. So I'll go over to Desmos. This is a great resource once again. So we're going to do, I'm actually going to type in the equation. So 3 times 2 to the power x. If you want to do a power, you can use that like caret symbol like that. And so this is what that graph looks like. So we can see how right here we said the starting value is where the equation crosses the y-axis. It's kind of like a y-intercept, but right there, that's the point 0, 3. And then if we go over here, you'd see 1, 6, and there it is, 2, 12. Down here we can get to -1, 1.5, -2, 0.75, etc., etc. So all those points are on there. You can see how this graph is starting very, very low and going up very, very steeply. It increases very quickly. And so a couple things we want to notice here. One, if we look over here at this table, we can point out that all of these values right here, so the 0.75, 1.5, 3, 6, 12, all of these numbers are doubling, and there's a reason for that. So in this example, the growth or decay rate was 2, and so that means that this graph is going to go up by multiplying by 2 every time. So that is what we refer to when you're talking about the growth or decay rate. In this example, we're multiplying by 2 a repeated number of times. So you're multiplying by 2 by 2 by 2. It's actually easy. Once you plug in one of these numbers, you don't really need to go over the calculator again and again and again. We just need to plug in, once you know one of those numbers, you can repeatedly just multiply by that thing right there. Another thing that I'm going to point out is that this graph in particular is, it's going, as we go to the right, it is going up. It kind of has, it's not a slope, but it is increasing. And so this particularly, we call this growth, because this is, this graph is going up. So that growth or decay factor is actually just a growth factor of 2. So we're going to be a little bit more particular about that. And let me take a little screen cap of this so we can insert it. Click. So I'm going to put that into our notes just so that we have a little reference for later. And we are going to go back to a new example. So we're talking about something a little bit different. So this example is 5 times 1/2 to the x. So in this case, the starting value is 5, and the growth or decay factor is 1/2. So in this example, again, we're going to plug in those values. So I'm going to start by, we'll change these numbers. So that's going to be 5 times, I can plug in 0.5 to the power -2. So here, 0.5 to the -2, that is going to give us 20. We can do this again with a -1, and that gives us 10. 0, that's going to give us a 5. Now where it's +1, got to make sure I get rid of that negative, so that's 2.5. 2.5 and 2, so that is going to give us 1.25. All right. So for this example, first of all, we can point out that, again, this value, that starting value, the 5, shows up in the middle where it's 0. And we'll go over the graph, change this. 5 times 0.5 to the power x. There we go. Didn't really need that. So here's our example again. That's where it crosses the y-axis. That's where it is at 0. And another thing we can point out, that growth or decay factor, so that number is, we're multiplying by 1/2 this time. And so the number in the middle is the 5, but it actually goes down to 2.5 and goes down to 1.25. So that number is going down by, we're multiplying by 1/2, but you could also say like dividing by 2, because multiplying by 1/2 and dividing by 2 are the same thing. So 20 divided by 2 is 10, divided by 2 is 5, etc., etc. So again, take a little screenshot of that. This is really loud. Okay. So as we look at these, this one, so we said earlier this example up here, because our graph is going up, that is growth. In this example, our graph is decay, because as you can see, this graph is going down, these numbers are going down over time, etc., etc. So that is called decay. That's what that means. And something that we can point out is that this factor is 1/2. That number is, of course, less than 1, and then this number is greater than 1. So that is actually a rule. Something is a growth factor. Growth when b is greater than 1. And decay when b is less than 1. So that's going to be a rule there too. So anytime this number here is greater than 1, so like if it's 2 or 3 or even like 1.2 or 1.5, it's going to be growth, and it's decay when b is less than 1. So an example like this, if it was like 1/2 or 1/3 or even like 0.9, even if it's just a little bit less than 1, that graph is going to go down over time. So that is it. If you guys have any questions, you guys are going to be filling out the tables in the homework, and you just need to answer things about whether or not an example is growth or decay and factors. If you have any questions, please let me know. Please come to office hours or email me. And good luck on your homework. Have a good day, guys.